Good day and thank you to the esteemed panel of judges. It is an honor to present our intellectual properties entitled Transforming Waste Plastic into Filtration Membrane, a Circular Economy Approach for Sustainable Development in Country. My name is Teo Yit Han. These innovations reflect our commitment to advancing engineering solutions that deliver meaningful benefits to society, industry, and the nations, in line with the spirit of Anugerah Harta Intellect Negara under the category of Wira InoVatif. This slide shows an overview of these intellectual properties. These intellectual properties focuses on transforming the post-consumer polystyrene plastic, which you can see at the left-hand side box here, into advanced filtration membranes that presented by the right-hand side box here, and the produced end product, which is the polystyrene membrane, can then be applied for the wastewater treatment and other industrial applications. Let's say this polystyrene membrane is used in the wastewater treatment processes, then we can obtain the clean water by using this polystyrene membrane through a filtration process. And through this, it will reduce the water pollutions, and at the same time, we can produce the clean water. The overview of these intellectual properties, it fulfills the concept of circular economy, whereby it reduces the plastic pollutions by using the low-cost polymer material and having a high-end product by applying the waste-to-gold concept. By converting a non-biodegradable environmental liability into a high-value engineering products, these innovations integrates material science, chemical engineering, and sustainability principles to address critical global and national challenges, which are the plastic pollutions as well as the water scarcity, through a single scalable solution. And this is an introduction of these intellectual properties. We know that the plastic pollution has emerged as one of the most pressing environmental crises of the 21st century. Due to its non-biodegradable nature, plastic persists in the environment for hundreds of years, accumulating across land, water, and even at the atmosphere. And you can see from this picture, it is depicted the plastic waste around the world. And from here, we also understand that among all this plastic, polystyrene is widely used as the packaging of food, containers, and yet remain underutilized in recycling due to its low economic value. By 2025, it is projected that 33 billion metric tons of plastic waste will have accumulated globally if current productions and disposal trends continue unchecked. And this figure is about the mismanaged plastic waste that is being generated around the world. You can see from this figure, they have different color that represents the levels of the mismanaged of this plastic waste that being generated. The dark blue means the lowest mismanaged level, whereas the color yellow, orange, and up to red color represent the high level of mismanaged plastic waste. Other than the plastic waste, at the same time, water scarcity and wastewater management are growing a global concern. Membrane filtration is then being emerged as a promising, energy-efficient alternative to conventional wastewater treatment processes due to its high efficiency and low energy consumption. However, the widespread adoption of membrane technology is still limited by high production costs and heavy reliance on virgin polymer materials, particularly in low-income, rural, or decentralized settings. These challenges highlight a critical gap and an opportunity for innovative engineering solutions. The primary objective of these projects is to valorize the waste plastic material, specifically post-consumer polystyrene, by repurposing them into high-performance polymeric membrane for water, wastewater treatments, as well as the industrial filtration applications. Through this approach, The integrated projects aims to promote the circular economic principle, reduce the environmental pollutions from plastic waste, lower the cost of membrane productions, as well as enable wider access to sustainable water treatment technologies. The implementations of these intellectual properties follow a clear and practical value chain. First, the phase polystyrene is collected and processed through clean and shielding, transforming the discard plastic into usable material. Next, the processed polystyrene is fabricated into filtration membrane using scalable phase inversion techniques, which is compatible with the industrial manufacturing process. To enhance the membrane performance, titanium dioxide nanoparticles are incorporated into the membrane matrix. The final product is a low-cost, high-performance filtration membrane that is suitable for the real-world applications and ready for technology transfer commercializations. The membrane is then tested by using the dead-end membrane filtration system for the applications of wastewater treatments, and we were able to achieve the clean water from this filtration process. And from our integrated intellectual properties outcome, we found that the permeate flux of as high at 166.55 liter per meter square hour is obtained with the rejections of more than 84%. The developed integrated properties have been found, and these developed integrated intellectual properties have wide applications across multiple industries, and this include the water and wastewater treatment, the petrochemical and oil and gas industry, food and beverage processing, pharmaceutical manufacturing, and so on. By enabling the local membrane productions, by using the recycled material, these intellectual properties also has the potential to reduce Malaysia's reliance on imported filtration membrane, strengthening the national technological capability and supply chain resilience. As a conclusion, this work exemplified a new generation of sustainable membranes by addressing two global challenges simultaneously, which are the plastic pollutions and access to clean water. The developed membrane demonstrates strong commercial potential across multiple industries, including water treatment, petrochemical, food and beverage, and pharmaceuticals, while delivering tangible environmental, economic, and societal benefits. More importantly, these innovations reinforce the role of engineering and scientific creativity in generating real-world impact. By transforming waste into valuable resource, this intellectual property contributes to environmental sustainability, national technology advancement, and improved quality of life by fulfilling and embody the objective of Anugerah Harta Intellect under the category of Wira InoVatif. Thank you very much for your attention.